All right, so 19B on the final exam practice. This problem is going to get a little bit hairy, so kick back and don't take it too seriously. All right, so either way, we want to show that this distributive property for the cross product holds. And so we're going to do this by using the definitions of the cross product and the sum of two vectors. So either way, just to start off, we're going to write the vector A as having components a1, a2, a3. We're going to write the vector b as having similar components b1, b2, b3. And we're going to write the vector c as also having similar components c1, c2, c3. All right, cool. And so now we can work component-wise with these cross products. So either way, looking at the left-hand side of the equation, I need to find the sum of b plus c, and then take the cross product with a. So let's first write the sum of b plus c components. So it'll be b1 plus c1, b2 plus c2, b3 plus c3. Now I want to do the cross product a cross b plus c. All right, so remember our cross product is just going to look like the determinant of a particular matrix. So we'll put I, J, K up here just formally. And then we put the entries of A, which is just A1, A2, A3. And then the entries of B plus C, so we put B1 plus C1, B2 plus C2, and B3 plus C3. Okay, so now we want to actually take the determinant here. So we do our row expansion across the first row. And so we're going to get this coefficient on our standard basis vector I. So we'll have the coefficient A2, B2 plus C2, A3, B3 plus C3. We take the determinant of this. This is the coefficient on this standard basis vector. Then we do minus the determinant of A1, A3, B1 plus C1, B3 plus C3 on J, and then we add the determinant of A1, A2, B1 plus C1, B2 plus C2 onto the standard basis vector K. All right, so we just need to compute each one of these coefficients. And so the first one's going to look like A2. I can just put it into this form because I know this is my coefficient on the first standard basis vector I. So either way, this is just A2 times B3 plus C3 minus A3 times B2 plus C2. Okay, my coefficient on the standard basis vector J is going to look like negative A1 times B3 plus C3 minus a negative A3 times B1 plus C1. So I'll write it as A3 times B1 plus C1 minus A1 times B3 plus C3. Okay, and then the third component is going to come from A1 times B2 plus C2 minus A2 times B1 plus C1. Okay, so those are the components of our cross product A cross B plus C. And so now I just want to split this up because I think it's pretty easy to see that the components here, A cross B, are just A2 B3 minus A3 B2, etc., all of the terms with the A's and B's. And then our cross product A cross C are just all the terms with the A's and C's. So if we split this vector up, which is very easy to do, I can just write it as A2 B3 minus A3 B2, A3 B1 minus A1 B3, comma, A1 B2 minus A2 B1. So that's our cross product of A and B. And then I want to add this to the remaining things that I left out of my components. So I left out an A2C3 from the first component minus an A3C2. And then I left out an A3C1 minus A1C3. And then from the third component, I left out an A1C2 minus A2C1. And this is the cross product of A and C. So I can write this now as A cross B plus A cross C. Okay, because this is A cross B here, and this here is A cross C. Okay, so that shows the equality between A cross the sum of B plus C and A cross B plus A cross C, establishing this distributive property for the cross product.